Hello, everyone. Welcome to today's lab session on relational data and SQL. We'll be doing more practical exercises. So there's a database that I have created on a Google Drive, which I'm also going to share the link for. So you can use that to make a copy of the database on your drive or save it to your system and upload it, which might be longer. But if not, just make a copy in your drive and change the path in your file. So I'll share my screen and then we can start. Okay, so I've left some notes in the notebook for you to be able to understand where the data is from, how to connect the DB, the database, and some of the SQL queries that we'll be using for this lab. So if you want to connect it to your Google Drive, you have to mount the Google Drive on Colab. So you can just do that by running this cell. Mine is already mounted. So, and then you can click run this cell as well. So if you upload it, that's when you need to run this. So create a connection by running this cell. Then also you need to import the libraries that we're going to use as well, and then run this, and then we're good to go. So for this database, I've created 4 tables, which is kind of similar to what Tayo is. It was a dirty creation, or would I say clean creation? Let me not call it. So I had to read the CSV file. I'm just going through, we're not going to go deep into this. I had to read the CSV file, create the tables, assign the data types, and insert the tables row by row. Sorry, the data row by row. So that's what I did to get the final results, which we have here. So we have 4 tables: the customer table, the sales table, the product table, and the returns table. It's very important to understand how these tables are, because that will help you in your querying. I think like if you understand the data on your tables, or the tables that are available, you can easily make the connections when you're writing your SQL queries. So for the customer table, we have the customer key, which is the primary key, the sales table, which has the which has the order number, which is the primary key. I didn't highlight it here, but the order number is the primary key in the sales table. And then we have the product table, which has the primary key as the product key as the primary key. And then we have the returns table, which has the product key in the returns table. That's the primary key. So for each customer, they have many sales transactions. And in each sales transactions, we have one. For this particular instance, we have one product to many sales. So you can buy something multiple times. And then we have one product to many returns. So that is an overview of the structure of the database. So, I mean, I've already said what the primary key of the customer table is, which is the customer key. So I guess there's no need for this question. So we're going to run through some SQL basics, and I like to use a select star. Like if you don't know what is in the table, for example, you're just meeting a new table, right? You're starting a new job somewhere, for example, and they've just given you this bunch of tables that, write the SQL query for us to get this and this, and you don't really know what the columns are or what the data looks like, then you can run a select star statement. So running a select star statement, we can see that this table has, and we're using pandas, by the way, to read the SQL. If you were using a normal SQL database management system, you would just write the SQL query But Pandas has a method that we can use to pass the SQL queries into Pandas using the connection, and then we can get the results from the query. So that's what I've used here, read pd.read SQL. PD is Pandas, and we put our SQL query in a string format, and then you pass the connection, which is one of the parameters for this method. So, and df, sales df.head 5 means bring out the first 5 rows from the query. So that is what we have here. So we're going to be doing a bit of Pandas and SQL side by side. I think, was it this? Oh God, I've forgotten what it's called. Lucid charts. I'm just typing lucid charts. That's what I used to get the entity relationship diagram. I had to do it manually myself. So that's what I did. That's what I used. So for this sales table, we have the order date, stock date, order number, product key, customer key. We won't go into much details, but this is what it looks like. So I'm just going to have to swipe to the right. Okay. So this is what the sales table looks like. And then for the customer table, this is what the customer table looks like. We have the customer key, which is the primary key in the customer table. And if you're doing a join, it will be the foreign key in the sales table. So you can see that these keys are very important when we want to join both tables. And we have the first name, last name, email address, income, education level, all of that extra columns in the customer table. Then I'm going to run the product table as well. And let's just see what it looks like. So we have more details about the products. We have the product key, the subcategory of the product name, the product SKU. That's probably like the barcode number or something. Then the model name, the description of the products, and all that extra information. You can run the cells if you want, but some of the queries are not included because I want us to do it side by side. So I haven't included the queries in the Colab notebook. So if you want, you can take some time to run this, try it yourself, run the select star statement. So all you need to do is just, I think the spaces are empty. So all you need to do is just type it in this section and run it and see if it works. Okay, and then the returns table. This is what it looks like visually. So it's just very helpful to see what the data looks like so that when you're running the queries, you can go back to, or you can even, sometimes I used to just copy and paste the column names so that I don't have to type it out again. But this is what it basically looks like. And then we're going to move on to statistical operations. So also there's something you need to note. There's something called an alias. So that is a temporary name given to a table or a column. You're going to see me use it a lot when I'm running queries. So it's a temporary name that is given to a table or a column that can be used and reused within the table. So for this first query, this is the alias count, and I've used this here because if I do not use this, when I run this code, it's going to bring out this as the column name. Oh, sorry. So let's just run that. So it's just a way of making your work more readable. And when you have things like aggregations, especially if you don't want to use the column name, you would rename it so that it looks more presentable or more understandable to whoever your end customer is. So I'm just going to leave that as counts because I use that to access this result here. So when I run, so count means to count the number of rows mostly. So it counts, so we have 6,296 customers in the customer table. So because I got the data from somewhere, I need to be sure that the customer keys are unique. So let's see. So that means there are duplicates in the customer table, because when I use the distinct is to get the unique values of the customers, of the customer key in the customer table. I hope that makes sense. So it's a keyword in SQL that's used to get the unique whatever role you're calling it, whatever column you're calling it on. So if you say distinct annual income, it will bring the unique annual income, for example. So that is just a simple way of doing that. And then we're going to do an average as well. So you can do average, minimum, maximum, count. You can do sum as well. So if you want to sum like the annual income, you could do like a sum, which would do a mathematical sum. So running the average, we can see that the average annual income in the customer table is 57,269.12. And then to get the minimum annual income, which is 10,000, you use the minimum keyword, min keyword, to get that value from the customer table. And then to get the maximum, you run the max keyword against the annual income. So there are different statistical operations, like I said, that you can run on SQL, right? We have count, average, minimum, maximum. We have sum as well. So also you need to know that you can run this on, I mean, you can do some of these statistical keywords on operations on strings as well. For example, like the min, you can do a min on a string, and you can do the max on a string, but you can't do like the average on a string, for example, because what's the average of someone's name, really? But you can do like count, average, minimum, maximum on numbers, numerical values on this table. Also, I think it's important to know that for SQLite, they don't really have a variety of data types. For example, they don't have a date data type, but you have to like cast when you write it. And also, so they just have int, text, real, and I think Boolean as well. So but in a normal like SQL database table, you can do more. So SQLite is just meant to be a light version of SQL. So it doesn't do like all the core SQL things, but you can get most of it done. But this is just the easiest way for us to, run SQL queries without getting into too much installation and things like that. So we're going to go to filtering in SQL. So now we know how to like select. Okay, sorry, let me add as well. So if you want to select multiple columns in SQL, you just add a comma and the name of the column. So that's how you add multiple columns. So if you want to filter on SQL, we have different ways to, we have different operations for filtering, which is kind of similar to your regular filtering. Regular mathematical operations like greater than, less than, equals to, greater than or equals to, greater than or equal to, not equal to, in, not in, between, and like. So I'm going to go through some of them and we can see an example of, some of the statements. So for this first question, we're going to get the products where the product name starts with universal. So this is a string operation that we're going to perform here. So we want to filter all the products. We want to get all the rows where the product name starts with universal. So when I wrote this query, I could see that. Can you see the first two? It starts with universal. So I wanted to get all the rows that have the product description starting with universal. So to do that, you are going to write. So ideally, also people say it starts with from, like a from keyword, which is where your data is coming from. So you need to know what table that is coming from. So the product name is going to come from the product table. So we're going to select product table. And then we want to see the product name. Okay, sorry, it's product description, not product name. But we want to see the product name as well. So we can select multiple columns, the product name and the product description. So when you're trying to filter in SQL, the keyword that we use is where, which is kind of like simple, plain English. So you want to select the product name, the product description from products where, in this case, we're using like where, we're going to use where and like. So where is the keyword for filtering? Where product description. And I'm going to show you some really interesting things when searching for keywords for words in SQL. So you're trying to match. So in this case, we're trying to match by seeing the words that start with universal. And to do that, we're going to enclose universal in a string. So I'm going to type the word universal. And because I said that we want product description where the keyword starts with universal, we are going to include a percentage sign after the word universal. So that means, so it's kind of like, give me words that match universal as the starting point, as the first string, and then it can be anything after. So that's what this basically means. So when we run that, oops, sorry. Oh, sorry. Like, I missed out. Yeah. So, okay, what's going on? Product name, syntax error. I think I should just start this thing from select. I actually like to do select. I tried to do a new method today and yeah, that kind of flopped. Okay, so we're going to select product name and product description from products where product description like universal. Remember, if you're trying to see what it starts with, then the percentage sign will be after the word that you're starting with. Does that make sense? So we're going to try the opposite now. So a case where the product name ends with black. So I've already gone through the table, so I know that, there's some words and products with names that starts with black, that ends with black. So for example, if you had maybe if you wanted to search for email addresses that ends with people that use Google Mail or Google email, then you would search with like statement and say, oh, the product, the email, and then you put the percentage sign in front, which I'm going to demonstrate here. So I'm just going to copy this select statement. So we're going to say where. So in this case, we're using the product name. So hopefully it doesn't confuse anyone, but we're using the product name in this instance. So it's also case insensitive, to be fair, but just try to write it in the right syntax or format so that it's a bit clearer. So if it ends with black, it's going to be the exact opposite of this. So the percentage is going to come to the front here. And then we run that. and then you see the results. So we have this product name, and you can see that it ends with black. So that's an example. So then we're going to try another format, which is when the product description contains lightweight. So in this case, we don't care where the lightweight is, as long as it's in the product description. For example, as you can see this row here, lightweight is in the middle, and we can't get the exact location. So it might be here in the next row, it might be here in the next row. So we are just going to use this format. So to do that, you would put the percentage on both sides of the word. So that would be product description in this case. So where product description is like lightweight, and then put the percentage on both sides. And then if we run it, yeah, we will see that. So I think for here now, for example, the lightweight is somewhere at the end. So yeah, a Colab has this thing where you can, so if you select, so if it's a table, you can select this and it will show you the result as a table. So you can see that they all have lightweight at some point in the column. Okay. Okay, so moving on. So when you're doing filtering as well, there's also something called having. And the difference between where and having is that having is used on aggregated queries. So aggregations are like count, sum, mean, max, those like aggregations that can be done using a group by. So have I done a group by? No. So when you do a count on a column, let me just copy this query out so I can run a brief group by. What's that thing? So if you want to count, for example, right, you can count on its own, or if you want to see a column, so if you want to count, like, for example, the occupation, I think we have occupation. So you want to count how many different occupations by annual income, or you want to do the sum of the annual income by the occupation of the users we have in customer table. And you want to select, especially if you want to select that column, like you want to display that column, then you need to use a group by. If you're doing a count on its own, then you can actually do without, using a group by. But if you need to see the occupation as well, for example, then you would need to do a group by. I'm on the right table. Yeah. Oh, sorry. I need to print out the results. Is everyone following? Is it making any sense so far? So I'm just trying to explain what a group by is so that I do not have to, so that I can explain the having clause simply or easily. Is everyone following? Okay. So if, for example, I want to get the, okay, I already had a group by year, actually. So let me just remove this. So I want to show you a simple scenario where we could use the having clause. So let's say we want to check the number of duplicates or rows that are repeated more than once. So maybe we want to know how many customers have ordered more than once in our table. We can do a count by the customer key. I think it's customer key. I hope it's customer key. Yeah, customer key. So yeah. Counts. Oops. Just going to type it. So let's do from the sales table, right? Because we want to know how many customers have ordered more than once. Where is that? So we're going to do group by customer key. So I'm going to use an alias here. So that's then we would use the having clause. Having. So it depends on the SQL management system. Some of them can let you just like directly use the alias, and some you actually have to do this count. So let's try this. I think SQLite lets you do there. You can use the alias. We use the alias. So let's see. Okay, it doesn't. Oh, sorry, that was me. Yeah. So what this does is after you've done the counts and then the customer key, and then you've grouped it by the customer key, it has run that as like a separate query in the back end. And then you're now kind of selecting or creating a filter that you want to return the customers who have the counts greater than 1. So that means they have ordered more than once from the sales table. So here you can see the counts. So this person has ordered 7 times, this person has ordered 10 times, this person has ordered 3 times. And that is just the difference between the having and the where. So in this case, you can't say where count is more than 1 because count that wouldn't work for aggregation. But you can say where anything else, maybe where customer keys equals to this number, or where customer names equals to this name. So if we run this, you see that it's not going to work. Let's see if it roots y. Okay, just a syntax error. But you can't use the where clause on an aggregation. So I'm just returning that back to the way it was. Okay. So then we're going to go into a little bit of date time functions as well. So SQLite has its own like dates formatting syntax. For some SQL database management systems, you can just like write call a keyword or a function basically and just be like date or extract month. So you have to always check with the syntax of the system that you're using. So we're going to get the number of orders for each month in 2015. So what this means is that for each month, okay, that's kind of, yeah, for each month in 2015, you want to see how many orders were placed. And by doing that, we need to extract the month. because the format is in a date. Let me try and get to the customer table. Sorry, the sales table. So this is the format we want to get. So we want to get the orders in January 2016, for example. We want to get only this, we want to extract this middle numbers, which is 0, 1. So that's what I'm going to show you how to do here. So we're going to just select. So the syntax for SQLite is string format time, which is kind of similar to what we have in pandas anyway. And then we do this. So I've included a link to the date formats at the bottom of this collab, so you can see more examples. But for this particular query, we're just going to use the month. And then we're going to put the order date as the column that we want to extract the month from. From sales. Then we want to count the number of sales. So I think we have order number. I think there's the column order number. So it can be any column that you want to use, but I'm going to use order number because I know it's a primary key, so that means it's not null and there are not going to be any errors. So count the order number as number of orders, and then we group it by month. So remember, grouping is when you're doing aggregations. Group by month. And then we want to see the number of orders for each month in 2015. So we're going to specify the dates. So where comes after the from? Ignore that I already did group by. So where comes after the from and before the group by? I think I'll try and see if I can add a link to like SQL formats or like structures, like what comes before what. So where order dates is between (2015) 0101 and this is getting long. So also, if you want to do multi-line strings, you use 3 quotes or 3 single quotes. Just make it easier so we can see without me having to scroll. Where order dates between 2015 01 and 2015 12 31. And then we'll run that and see. Okay. Okay, new group. Oh, sorry. Right. Oh, it's truth. Sorry. So you can see that. Yeah, so you can't use the month function in SQLite because they have their own syntax of how you can extract dates. So for this particular one, you have to use string format time in SQLite. But for most database systems, you can use month. So yeah, we have the number of orders grouped by month, and yeah. So we can try other ones actually. So we can do day of the month. Let's try day of the month here. This will probably be longer. So I'm just going to reduce the dates range. Yeah. So you can experiment with other date and time functions as you please. So we're going to go into joins. So this is going to be a bit interesting. We're going to do joins using pandas and joins with SQL. Okay. So basically what a left join does is it returns all the rows from the left table, even if there are no matches in the right table. So I'm just going to create a simple query to do a join and visualize it so you can kind of see what it is, what it looks like. So I'm going to join the sales table and the customer table. And the primary key on the customer table is the customer key, and it will be a foreign key. So we're using the sales table as the left table. So the customer key will be the primary key, in this case, on the sales table, and it would be a foreign key on the customer table. So to do that, I'm going to write the first statement, which is select, which is how you retrieve all the rows in the table. And then I'm going to say select star, because I want to see all the rows from both tables so you can kind of visualize how the join works. So select from actually, we're joining on the customer table. So the customer table is going to be the left table, and the sales table will be the right table, but we're doing the left join. So the customer table is the main table. So being left means like your actual visual left, and right is your visual right, like your actual right hand side. So select from customers, or select from customer. Select star from customer. So when you do a select star and you are joining two tables, it's going to bring all the columns on both tables, unless you specify the columns that you want. So I'm going to say left join sales on. So in this case now, because this two tables have the same name for the keys, we are going to create an alias, or you can just copy it directly. Copy the table name directly. So I'm going to say customer table is A and sales table is B. Also, aliases, you don't necessarily have to put as, you can just leave it like that and it would automatically assign that alias. But I like to just put as so that it's not confusing, or I don't mistaken it to be another column. So you will see where the alias comes in play. So we say A, the customer key is equals to B, the customer key. Because if you don't put the alias, it wouldn't know which one you're referring to, which could actually cause an error when you run the query. So I'm going to look for a particular customer, because I don't want to return many rows. So I'm looking for a particular customer. So I email and close that. Okay. So you can see the customer's details on this side, which actually shows you that. So because the customer table is the left table, it gives you all the columns of the customer table first. And then it gives you the columns of the sales table on the right, which is what we have here. So that is just a visual. So if you can kind of visualize it, then it kind of helps to, understand what you're doing. Yeah. So when you want to do that on pandas, you use what is called a merge, and then you do pd.merge, which is pandas.merge, and then you put the right table. So in this case, sorry, the left table. So we're going to put customer here and sales here. So the customer table will be the left table. And then we'll specify left join, and we're joining on the customer key. So let's run that and we can see. So this one, I didn't specify the customer. So it's just returning all the rows, or the first 5 rows. So that is how it works in pandas. I hope that makes sense. Is everyone following? Because it might get a bit tricky now. Okay. Okay. So I'm going to, I already wrote the query here. So we're going to do a little bit more complicated left join. So I've selected the sum of the order quantity. So I want to get the order quantity of the total quantity sold using the product and the sales table. So I'm joining the two because the category name is not in the sales table, right? It's in the product table, and I need that information for my question, right? What are the top 5 categories sold? So to get that information, I need to join the sales table with the products table, right? So that's what I've done here. So select the sum order quantity as quantity sold, then the category name, which is from the products table. And I've joined both tables on primary key, on the product key, sorry. And then I've grouped by category name, because there is I've selected category name. Remember, if I didn't select category name, I can do without grouping by. But because I want to see the category name, I need to group by, so that I can group it by the category name. And then I'm ordering it by the quantity sold in descending order. DESE is for descending. If you do not put DESE, it is going to return the ascending order. So to specify that it's going to be the descending order, you have to put the descending order. And then I'm limiting it to 5 to give me the top 5 categories sold. So that is why the query is like this. So limit 5 gives you the top 5, because I'm ordering by descending order. If I leave it as ascending, to give me the bottom 5. So let's run that. We already have 3 categories, which is accessories, bike, and clothing, because our database is quite small. So we already have 3 categories. So yeah, these are the top 3, or to be honest, all we have. But ideally, if we had more categories, then we could, get more. Let me see if there's any other example, any column that we can use, which will probably have more. Okay, so we have subcategory. So if we do subcategory, then we should be able to see the top 5, because that will be on a final level. So let's go to, yeah. Also, if you can group by, whatever is in your group by doesn't necessarily have to be what's in your select statement. Like I can group it by the subcategory name and group and select the category name, but it wouldn't show the subcategory name. You would just see like multiple rows of accessories, and you do not know, what subcategory it belongs to. And also is whatever group by, whatever column name that you're using the group by, that it would actually group by. So even if you select category name here, it's not going to group it by this higher level category name. It's going to group it by this subcategory name because of what I did, the query I wrote. So let's run that. So yeah, we have the top 5. So let me select the subcategory name so we can see what subcategory it belongs to. So yeah, so the top subcategories are tires and tubes, bottles, cages, helmets, mountain bikes. So that's about it for the left join. So for a right join, SQLite doesn't have a right join, but ideally, if you had a right join, you would just type the right join. I hardly use right joins because, to be honest, if you really want to right join, you can just, put the column, the table that you want on the right-hand side. So for example, if you want your product to be the right table, then you put the product table on the right and then have it as a right join. But if you're using a left join and you want your product table to be, the main table, you put it on the left and then just say product left join sales. Hope I'm not confusing anyone. So let's try this example. So select start from products. All right. Let's do the alias because the keywords are the same as a right join. Oh, sorry, left join sales. As B on A dots. I'm just going to copy that out because I'm still doing the same. Sorry, I'm such a fan of copy and paste. Okay, that's A. And then, so you can see that, the product table is on the left-hand side, but if the point is, if you want your product table to be the main table, you know that when you're doing a left join, it would return all the products, all the rows in the product table, even if the rows don't exist in the sales table. So that's essentially the whole point. So you can see that, there isn't an example here, but ideally, if there were some products that didn't exist in the sales table, the sales value would just be null. I'm trying to see if I thought I had an example. I think it's on another table that I had an example of what it would look like, because all the products actually exist and vice versa. So we can't really visually see that in this example. But as we're moving on, we'll see more. And then obviously, if you're doing it in pandas, you would just do the same and just specify which one is the right and which one is the left. So I think here we're doing the products, the sales and the products. Okay, let's actually just do the customer and sales table. Okay, so this is a good example, right? So on the sales table, so not all customers have sales, like not all customers have done transactions, and that's why you can see some null values on this on this side of the table. I don't know if that's making any sense. So some of the customers haven't done transactions. So the right table is the main table, which is the customer table. And that's why you can see that there's no NaN value on the right table. But there are some NaN values on the left-hand side because not all customers have done transactions. So this is a very good example of what it looks like visually. So simply put, the right join would give you all the tables on the right-hand side, even if there are no matches on the left, which is kind of what I have shown you here visually, right? So we're doing the right join, and this is the right table, which is the customer table. So we have all the values. There's not going to be any value that is NaN. But because the left table, some customers haven't done any sales transactions, which is table on the left, which we have joined, but we're using a right join. Remember, the right table is the primary table, is the main table. So that is why we can see that there are some NaN values on the right-hand side. This has a value because we're joining on customer key. So there is a value for the customer key. But all the other columns in the sales table don't have any values because these particular customers have not done any transactions. Okay, so we're going to do the inner join. So an inner join returns like all rows from both join tables with matching rows based on the join keys. So for example, if we're doing an inner join for this, these customers wouldn't show because they don't have a sales transaction. So they have to have matching values, meaning that you can find the keys in both tables. So for example, this key, if I'm saying, oh, we're checking for this customer ID, and we're trying to do an inner join for the customer table and the sales table, this key must exist as a customer key in the sales table and in the customer table. So just going to go through that quickly. Start from sales with a So for this example, I'm going to use let me just use the user table because not all customers have transactions. Okay. I'll just type out. Okay. Let's do limits 5. So these customers exist in the customer table and in the sale table. And you can see the details on the right. Yeah, and you can see the details. There's some duplicates in the customer table, so ignore that. So yeah. Can do it. Okay. And then if we were to do the same in pandas, you just specify the how and say the how should be inner. And then we run that. Yep, so it would give the same results as you can see. So yeah, that is it for inner joins. I think inner joins are probably the most straightforward. Doesn't have too much, trouble. So we're going to do an outer join, which is like a full join, meaning return all the rows, even if there's no matching row or not. So the full join is actually the same as an outer join. It can be used interchangeably. It depends on which, yeah, actually. So I've done that here. So I'm just going to delete this. But to do an outer join in pandas, you would specify. So the outer join is the same thing as the full join. And yeah, I've already done. Let me just move this up. Okay. So unfortunately, right, SQLite doesn't have a full join. So even if we run this, is not going to work. But on some other like SQL database management system, it would probably work. For the outer join example. Okay, what did I do filters? Okay. So I'll explain this when I run this. Okay, so to do, let's just do the full join first. Sorry, the outer join. So when you do the outer join, it's going to return the columns on both sides. But the thing is, so if there aren't like matching columns, some of the values will be null. For example, if I'm doing like if this is a sales table and a product table, for example, okay, the product table and sales table are probably not the best because all the products exist in the sales table and vice versa. So, but basically what I was trying to show is that if you do a full join, for example, let's say there's a product that nobody has bought, right? So that means it's not going to exist in the sales table. That means the value for this column, the way you're looking at it visually, the values here will be, is that sales? Yeah. The values here will be null because the customer has not done any, the product has not been bought, right? But for the sales table, if you do a full join, there would be a corresponding product because we didn't buy the products from thin air, if that makes any sense. So this is not a very good example to show where some of the where it might be null or where it would be null in the example. So I think we should just skip that. I was trying to show visually how, one of the columns could be null. But let's see, let's try with the no, unfortunately, this particular database that we have, all the products are in the sales table, so none of this is going to work. Okay. So the way a cross join works is if there's a single value, so for each value so we have a table, right? And there's like 4 rows on the first table and 4 rows on the other table. Basically, what a cross join is going to return is 16 rows. So for each row in the first table, it's going to return the matching, it's going to match the second, all the 4 rows in the second table. So let's do an example of cross join. I know some pandas fan would probably prefer pandas cross joins. Someone said AI will take over SQL. I'm not sure how, but good luck. Maybe sometime in the future. Probably I won't have to write in SQL queries. And then ChatGPT can just do it. So we're going to cross join the customer table and the sales table. So also for the cross join, you don't necessarily need a key because it's just going to return all the matching rows on both tables. Sorry, it's just going to return all the rows on both tables. So let's run that and see what it would return. Okay, my system is going to crash actually. Yeah. Let's see. Okay, because I limited, that worked. Okay, so you don't need a join in this case, and it just returns all the values and returns so it doesn't match per se because it's just returning. So for example, you can see this product key and this column, this product key or this order number on the order table is matching all the customer. So for this order number, right, this is one order number. It's going to match, I think we have like 100K customers, or it's 26,000 customers. It's going to match that one column with 26,000 rows. So there's going to be 26,000 instances of this particular order number. I don't know who uses a cross join or whatever they use it for, but I don't know. I don't know what scenario someone will use a cross join. I don't know. I can't think of anyone, but basically that's how it works. So it will just return all the rows and attach it to like every single column of the first row, the first table. Hope that makes sense. I can't really show it because it would be a whole lot of like rows. It will be the number of rows in this table, in the sales table, multiplied by the number of rows in the customer table. So yeah, and this is how you do it in pandas as well. So for this case, I selected just this product and just this customer so that it doesn't so it's not too much. And I saved that as a new DF called sample DF so I can reuse it and I don't overwrite the sales DF that we're using. So that's why I created a new DF as a temporary DF. So we're going to run that and see the results. So it would definitely be more than this number of rows. So, but it's just good to see what it looks like. So now we're going to go into something, we're almost at the end. This is just a bit more complicated. We should be done in like 20 minutes. Sorry for taking your time. So there's something called CTEs in SQL, which is, the full meaning is a common table expression, which allows you to create temporary tables that can be used within a SQL query. So once you cancel that query or erase that query, that's gone. Like it's not stored somewhere. It's a temporary table, a temporary, I don't want to call it view because a view is a bit more permanent than a CTE, but it's a temporary table that you can use in your queries. And I'm just going to go through a few examples. So how to create a CTE is use the with statement and then the name of the table. So for this example, I think I should give it a nicer name than A because I like to use A. So sales, which is the name of the CTE that you're creating, with A as, then you open parentheses, and then this is where you write your query for sales. So for this example, I'm going to select all so we can, select some columns later on. So select star from sales, and I want to see the sales, the rows of the sales table where the product key. Sorry everyone, hope you found the quiz amazing. Sorry I just jumped into the class back. I just don't want to take too much of everyone's time since we're kind of like running late or behind. But I hope you enjoyed the quiz. If you failed the question because maybe something isn't clear, please let us know, or just you can ask your question while So I'm going to limit it to 5. So what's going to happen is that this temporary table is going to only return 5 rows because I put limits there. I don't necessarily have to do that, but because I want to like show you for this example that. So this is like imagine that we have an actual sales table. No, don't let me call it sales. We have a table that's called sales. Sales outputs. So I'm just going to sales outputs. Yeah, because it would clash with the other table. That's 0. So imagine we have like your normal table like this. So it's going to look something like this. And then we have just 5 rows, which I would show you in a bit. And then I'm going to say, okay, sorry, that's within this. Let me come out of this parenthesis. Okay. So where product key is equals to this limit 5. And then I'm now going to say, because this is now a table on its own, this select sales output is a table on its own. Then I'm going to say select, and then I want to pick a couple of rows that I want to see, because I don't want to see all of it, although I put this star here so that all the columns are available. So also one thing you need to know about CTEs is that if you don't put, if I decide to specify a column, right, when I want to query from that temporary table, if that column wasn't listed here, even though it's in the actual sales, it's going to throw an error because I didn't put it here. I'll show you an example soon, but let me just, write this. So select date, order number from sales outputs. So when you run that, it will return the 5 rows from that table. So if, for example, I only put order number as the column in this temporary table. When I run this, it's going to throw an error because the order date doesn't exist in this temporary table. So if I want to be able to query this order date, then I have to have included it in this query. So that's what I'm doing now. Yeah, so that will work. And then window functions, we'll not get too deep into window functions, but I'm going to cover it a little bit. So window functions allows you to perform calculations across a set of table rows, which are somehow related to the current row. So in, let me see how best to, so in window functions, right, you can create a subsection of your table, which is called partitioning. So if I say I want to partition by order number, it would select, so if there are like 5 rows of this, if I'm partitioning by order number, and there are 5 rows in the sales table that have this order number, it will put the 5 rows with this order number together visually, like the way of seeing it visually, right? And then it will now perform whatever aggregation that I'm specifying on that particular partition. So I'm going to try and select that particular product order number so that we can see. So we can visually see how the partition works. That makes sense. So select star from sales where, although the order number is unique, so it's probably not a great example. But let's see if it's duplicated. I don't think it is. Okay. We have multiple order numbers. Okay, that's good. So if I want to do the minimum, order number, right? So let me order it by, so you can also visually see what I'm about to do. Order by order date. So you can see that this, okay, there are multiple instances, but this date is the first order date for this particular order number. And to do that, to write a window function. So I'm going to show you what it looks like now. So we're going to do select sales. Okay, no. Okay, let me just do the minimum order number over. So these are the keywords for creating the partition. Partition by, and I want to partition by order number. From sales. Okay, so I'm going to give this a name as well as an alias, I mean, minimum or first order date. So there's something we actually have to do if we want to return the first, if we want to return the first minimum dates. Okay. So this is where a CTE might actually come into place, because we want to select the first instance of the order number, because if not, it's going to return that query with multiple order numbers, or multiple minimum order numbers. What's the error here? Near over. Oh, sorry. This is my mistake. The order number. Order by order dates. Okay. Oh, sorry, my typo. How do you spell partition again? Just partition. So I was meant to select the order date. Sorry, not the order number. So this would return multiple, but so that's where the CTE comes in. Okay, so I'm just going to include the CTE because I want to return the minimum dates for this particular order. Okay, I didn't specify the order here. Okay, let me just specify the order because it has returned the minimum for each order. This order number is equals to That's wrong. Okay. Yeah, okay. So this is going to return multiple rows because for each instance or for each record of the order number, it's going to return the minimum order dates. But I think for this example, we might have just the same. Maybe I should use the stock dates. That will probably be a better example. So yeah. Stock dates, and then select order dates. Dates. And I'll have to, I need to group by, okay, no, I didn't need to. So let's see the example. So in this case, you just do a sum. It's literally the same thing, and then you just do a sum of the transaction value for this example. But let me just get to this example, which you can use with a CTE and a window function. So what is the top selling product in each region? So for each region, I want to see the top selling products. So that means the products with the highest number of sales and the very first one for each region. So let me just write the query. Maybe it would make more sense. So I'm going to create a temporary table with top as select, and then the sum of the order quantity. Because I want to know how many orders. If we're running out of time, sorry. That's quantity sold. I want to bring up the product key. Product key. Region. Then I'm going to do a partition to get the first row. So it's going to partition it by region and so it's going to get the sum of the order quantity sold. Then it's going to group it by the region. Then it's going to return the top value. So I'm going to order it by, there's an error. Okay. Thanks. Order by quantity sold. It's just by the sum of the order quantity in descending order. As number. Oops, going towards the left. And then I'm going to do, so I'll explain this in a bit, but let me just, yeah, it's not added my form. Just leave it as region. Sure, product key. Region, product key. Okay, so what I've done is to create a temporary table, right, using a, okay, I didn't put that in the brackets. Selecting the order quantity as the quantity sold, selecting the product key and the region, then creating a window function using the row. So there are multiple functions that you can use: row, rank, I think average, minimum, it depends, but there'll be a link. I'll find a way to attach a link later on. And then assigning that to a row number. Oh, sorry. It should be closed in a bracket. So I've created a partition by region, and we've added the order quantity, and it's sorted in descending order by row number, meaning the last row will be the quantity with the highest number, the sum of the highest quantity. No, the sum of the quantity, the total sum of the quantity, and the highest one will be the first. So by doing a select star from top where rank number is equals to 1, I'm saying that select the first row. Okay, I did not. Sorry, it's row number. That's row number. So where row number is equals to 1. So it's going to select the first row. Okay. Near select, top as select. I think I've not closed one bracket somewhere. Yeah, okay. So it should be here.
Okay.
Yeah. So hopefully, okay. No such form. Row number. Oh, sorry, row number. Yeah. So for each region, you don't need to return the row number, but let's just see it. So for each region, we have this particular product key and the quantity sold. So this is the top selling quantity in this region. If I were to remove the row number, it will return just the limits. Okay, no, let's not do limits because you might miss out some other regions. So you can see that for Australia, we have multiple rows. I don't know how many, but for Australia, we have multiple rows. So what we've done is return the row number with the highest, the last row number, because we assigned the row number to the quantity with the highest number, which is 1523, and we return the row number where is equals to 1.
So a question, please.
Yeah, okay.
Okay, so why do we have parentheses after row number?
Where?
At the row number in caps lock.
Parentheses. So that's just the function. That's how it works. If you do row number rank, I don't know what the explanation will be, but yeah, it's a function, like a Python function. So it's assigning a row number to the items in this partition.
All right,
That's
ma'am.
already the explanation for it. Yeah. Yeah, we're basically done.